Okay, everyone is just filtering in now. I can see everyone's the numbers coming up here. So everyone, we're just going to wait until everybody is in. The numbers are still running up. Okay, great. It looks like we've stabilized. Just going to do a quick audio check. Can anybody hear me? Here we go. Yeah, it does look. Says that. Everyone in the audience, can you hear me? If you can put something in the questions box and just say yes, that would be great. Just let me know that you can hear. We just want to do a really quick one. Yeah, there we go. Awesome. Thanks, everyone. Sorry, just a person on our side couldn't hear it. Well, brilliant. Hello and welcome to New Energy Update's latest webinar covering aftermarket technical and operations support for the wind industry. My name is Ben, and I'll be acting as the host for this webinar. There's currently about 700 people signed up, which is fantastic. So thanks very much for the great response. This webinar is going to last around about 60 minutes, but perhaps it could cut short, and it is being recorded. So don't worry about the recordings. They'll be sent to you probably on Monday, if not tomorrow. And that'll be audio and also the presentations as well. As you may know already, we're running this webinar in conjunction with our upcoming strategic event in Dallas on April 16th and 17th, which is all about Wind O&M topics. It's a pleasure to have Siemens Gamesa as a strategic partner for us, with us at the event. And it's going to be a really fantastic forum for key stakeholders to sort of interact and share knowledge and things like that. It's my pleasure today to introduce Sam Tasker, who's the Aftermarket Manager at Siemens Gamesa. He's going to be leading the discussion today. Sam, great to have you here.
Ben, thanks for having me, and thanks for setting this up from New Energy Update. And yeah, very much looking forward to. Yeah, can you hear me, Ben?
Yeah, we can hear you.
Okay, great. Very much looking forward to this morning, and in many ways carrying on the conversation with everyone out there at San Diego in a few weeks, and then at Dallas in a few months. This is the first time I've ever had the opportunity to host something like this. So I wanted to take a moment to introduce myself and then kick off a theme that I hope sets us up for an interactive session rather than me pontificating on all of the nuances in the industry or in the aftermarket, or for that matter, for Siemens Gamesa. And so with that, I'll just introduce myself briefly. I've been in the industry over 10 years and have had the benefit of working on the owner side with a few large owners, as well as now on what we all call the manufacturing side with Siemens Gamesa. That perspective has been very helpful for me to meet many people, of course, but then to see different perspectives with different business models and with a style that I think really strive to do, which is to find mutual benefit and partnerships with folks out there. So many of you who I've worked with, I hope would attest to that. And for those who don't, my effort today is not to sell anything. It's really for us to look at each other's perspectives and figure out how do we help each other's businesses. How does that benefit the wind industry? And how do we go forth into the next 10 years with a very dynamic industry? I think for many of us who started 10 years ago, and for those who started even before that, we've all seen dramatic changes in everything from the workforce to our technology, to the way we're looking at the methods we use on a day-to-day basis to keep turbines online, and now these big terms like digitalization, artificial intelligence, and other terms of the future that are now here upon us. So that's a quick introduction of myself, and I'm going to kind of go into a little bit of the first section of the presentation to define what we're talking about when we say aftermarket. So this is not a thing that I tell everyone here that owners have a department for. There's no aftermarket industry. There's no aftermarket commodity. There's no aftermarket department on an owner's team. It's a combination of typically three types of things that I've captured on the screen. And I think that's very important that we stop and break those down, especially in our conversation today. As questions come in, we should think about the different segments within our operations and how we're all supporting those. And so I suggest these are broken down into three ways that you see on the screen. For the first being modernizations and upgrades, a term that's been used in the energy industry for a long time. We've all heard it from fossil, and the same applies in wind. Enhancements, and those things can be characterized on the right with things like software, hardware, diagnostics, SCADA, tech support. One of the other areas that kind of fits in there but kind of doesn't, you see on the right, and I think it's important to capture, especially in the past few years, the introduction of things such as the repower 80-20 rule, overhauls, and life extension. Oftentimes those terms are used loosely and interchangeably as well, and I think it's very important to be very specific with those, especially if we're working outside of our region with other parts of the world. Those may have different definitions as well. Our second segment in the aftermarket typically is pretty simple with spare parts. Those are not just spare parts either, so I think it's important when we talk about spares to break those down as well, because those have different markets, different needs, and different applications, and those are all managed differently within everyone's company out there. And that breaks down into primarily three groups: the major components, the maintenance parts that keep a unit from being online, and then the consumables, the things we use in a recurring basis, just like you do on your automobile. Finally, the last group is something we call advanced maintenance. I think it gets some different names from different places, even within our region, where you have up tower services. You might call that major components, heavy lift. And so those are all the things that are characterized with what we all use crane and craneless major repairs for, down and up tower repairs for other areas of the turbine that aren't on major components. And then finally, a little bit of a specialized area with all of our fiberglass teams for blade inspection and repair. So that is a broad classification for the aftermarket that we can use to reference back to, and I have a little sliver of this on each slide as we go forth. So I want to kind of pause there and shift gears to a session that will only be successful with your interaction, so that I will not again assume I need to educate all of the folks out there on the phone today in our great region, but instead to really pose some questions and get some ideas from each other, as I said when I started, about ways we can help each other's businesses. So Ben, I'm going to pause there before I get into that interactive session to see if you have any other comments or if there are any other questions from the field.
Yeah, we've actually getting quite a few questions in now. I would like to remind everyone before we start fielding all these, first of all, to use the question function on your GoToWebinar bar. It will be able to shoot a question to me and I'll relay it on to Sam. And also, we have the slides, which I should be sharing with you right now. Let's have a quick look. You should be able to see those there. I will share the slides with you as well. Okay. We've got a couple of questions in now. Sam, would you like me to reel those off first?
Yeah, I think so. If there's any clarity needed on definitions, I think that's very important to do up front, so we speak on the same points going forward.
Yeah, we've had a question come in about cyber. So not many of the questions are actually about the clarifications around those three terms. Would you like to sort of move on and delve into the rest and then talk about those questions at the end? Let's do that, and perhaps those fit into some of the points we're trying to bring up here on the next three slides. Okay then. We go on to
the first question. And what we're looking for here is really what do we expect? How much technical advice is the industry expecting from the OEMs when an owner is no longer paying for service? And so therefore they're off of a service contract, and they still need some kind of operational support. And to jog everyone's thought, I threw up some terms there that come up in different pockets. Of course, there's the SCADA, the thing we use to interface with the asset, and in many ways something that falls into that cybersecurity realm, and some of the challenges we all have with securely accessing assets from different companies. Turbine software, controller, and parameter access, we know that is not something that is equally managed between different OEMs and partnerships. Part support and configuration, and then the work instructions, and then anything else. So again, how much advice does an owner off contract think they should get, and how does an OEM help someone with operational support?
Great. So that's for the audience there. You see those questions there. What sort of technical advice are you expecting from the OEM when the owner is off contract? So whether you are an owner or whether or not you work with owners or you just want to provide opinion, let us know in the questions and comments saying which ones you expect the OEM to support an owner with. Let's have a quick look there. So we've got a couple of points about clarification and then just asking about different roles and how much they play in the aftermarket. So we've got a question that's come in for you, Sam, that says, how much of a role does cybersecurity play in this right now?
Cybersecurity is a significant role, and it's growing. I think it is such because we know, all of us know, some of those standards have started to change over the past few years, many of which now require owners to do certain things at certain times. We see variation as well based on those same regulations that affect owners based on the impact they have to the grid, with classifications such as small, medium, and large, locations of the assets, control points, and those of course fall into typically physical security and network security buckets. So we're seeing that more and more, and we have helped in many ways customize solutions for owners, and that's indicative of us evolving rather than having those things packaged. And we're starting to have those more and more commoditized as we understand and catch up with the new regulations to support owners, because the owners have varying levels of sophistication. Some are able to do that in-house, and some are not. So in general, I would say this is a significant impact and has high visibility globally as well. While we all know what NERC is, there are other standards organizations globally that are tackling the same topic. Great.
Really, really good. There's a lot more questions and comments that have been coming in now, so I'm just going to reel through them, which is fantastic. So we had a contributor say that software and controller and parameter access is sort of the advice that they expect. Is that something that is common to you? So that's 2 and 3.
So I'm going to break those up. I think so for software access. I think about my cell phone and how that thing gets an update every once in a while for bugs, and similarly, we're able to do that with our turbine software, where we're maintaining a connection and have service contracts, and where we don't, we're able to support owners with that over time. And that has multiple advantages. It has advantages to the turbine ability to troubleshoot itself, and remote troubleshooting, fault improvement as we develop software improvements over time, and also different patches and things of that nature with that cybersecurity topic that come into play. Those softwares and controllers are often one and the same. Sometimes they're not. And I think the controller philosophy for many owners is that we see that as a proprietary feature, and we see that as something that we've developed to make sure that asset runs properly for many reasons, including safe work, as well as proper asset performance. So we're willing to work with owners there, and we've started exploring ways to give owners more access to the controller, but I think that's been a challenging topic in the wind industry, and of course there are some competitive challenges for us to figure out how much of that we open up in an open architecture format versus how much we keep control of for the design control and other factors as well.
Okay, great. Thanks very much for that, and hopefully that answers sort of some of the questions that the questioner may have had. Loads more coming in now. A lot of people talking about SCADA specifically, and part support and configuration too.
Okay, and I guess on SCADA, one of the challenges I think I'd like to share with everybody is that we see that our computers develop so quickly. I know we can all remember, I don't know if you all remember, getting your first email address when the internet came out. I actually remember that. I'm starting to become an old person. I remember when the internet first came out, and the discussion at the coffee shops, and I wasn't going to bars at the time, but and other places was, are you going to learn how to get online? Are you going to get an email address? Do you use the internet? Now, you would laugh at that type of conversation, but that was really only, about 20, 25 years ago. And since then, we've seen such a change in the computers, and those are what's running SCADA systems. If you go in and look at these are the same types of computers and servers you would use in many cases at home. Most cases they're a little bit more industrial, but you would see those in other industry applications as well. And those things are growing because the storage capability is changing. The demand on accessibility and data is changing. All those reasons I think most of us know. My point is, because of that, the requirements to keep those updated with hardware and software that support each other, with the demands from our businesses that we put on them, as well as just the fact that those things do go bad over time, make the configuration very challenging when we work with owners on that. Whereas, we can't change one piece. We have to change multiple things at the same time. So in as much as we continue to improve, I'd like to see the SCADA systems get more streamlined, support older versions, have fewer configurations, but we haven't got to that point yet. So I think one of my comments for owners managing SCADA systems is to look outward, to look 3, 4, 5 years ahead on what the expectations are for your equipment. Think about how you're planning on capital, and be considerate of some of those changing needs in the computer industry, as well as the configuration challenges that will come up when you have a SCADA type of issue.
Okay, great. Thanks very much for that. And again, loads and loads more very, very long comments coming in as well, which is fantastic to see that people are passionate about this and have really strong opinions and things like that. So I'm going to try and get through them as fast as possible. So one commenter has said that all of the technical advice that you've mentioned there is basically what they would expect from the OEM, but one that they would really single out and request support on is parts that have known defects. They have a site where they have defects in generators, and they need advice on modifications that can be made to the turbines and things like that mitigates high rates of failures. Anything that they can get from that would be greatly appreciated. I think what they're trying to hit on there is a more of a greater conversation between the two actors there. Is that something that within Siemens Gamesa you're actually talking about as well?
So yeah, those are nice, challenging questions. And there's so many scenarios out there. One of the factors that's tough for us is where there's an issue happening with equipment where we're not servicing it. Oftentimes we share similar problems on those assets where we are servicing, but sometimes we don't. Oftentimes we know the failure modes, but oftentimes we don't. So as opposed to generalizing, I think one thing I try to do is to let folks know if we do have a solution, and if not, that we're transparent about what the situation is, so as not to try to keep an owner or force an owner to work with us if there are better solutions on the market. And I need to be careful. I don't get into any particular failure modes or model numbers, but I think most of us in North America are familiar with magnetic wedges. We've come to look for those more and more. We would all love to know there's a detection method out there, but unfortunately, that generator example you brought up is one which so many of us know we have to do by running to failure, and it's a reactive part of the business, like most reactive things we aren't doing well with as an industry yet. So just from a philosophical point, I think how I like to try to approach those. When we know things, we certainly do try to connect owners with those, but at the same time, many of these challenges we also share. And believe it or not, I find working on the manufacturer side, we are much more transparent about than I used to think manufacturers were. We actually are very good about that, and don't sit around tables talking about what we should and shouldn't tell people that puts our company at risk. I thought that's what manufacturers did when I was on the owner side, and I haven't ever seen that happen. Are there any other points to expound on that, Ben?
Nothing that's come in recently, but I will ping back on that if there's anything that we can follow up on. A lot of what's coming in now is talking about data analytics as well. If we can have a quick chat about that, that'd be great. So a lot of people are saying that we basically need to get, I guess, smarter about data analytics. So a couple of commenters are saying we need data analytics from basically day one. All points need to be logged on, 10-minute intervals, as well as change of state. People are talking about what sort of technologies, things like that, what sort of implementations there are. There's a lot of talk around the data space here. So when you look at digitalization, data-driven O&M, whatever you wish to call it, how do you see sort of the issues that are being faced right now, and what sort of solutions are you exploring to sort of combat them?
Sure. Yeah. First of all, as far as helping owners get the data and data granularity they need, I sometimes wish more people would ask. I also find that there's a vast gap understanding our assets and the things they can do. Both again when I was on the owner side and now on the manufacturer side, with people running these assets, everyone from the operators in the field to the engineers to the asset managers, who sometimes are overlooking things that these assets and that our existing SCADA and analytics are capable of that we're not working on together. I really think we need to ask that more. So if someone asks me if they can get more granular data on assets from our fleet, there are ways we can do that. It isn't something though that typically is set up out of the gate, but they're all options when turbines are purchased, and they're all options when aftermarket sets in, and if an owner needs it, that we can support people with. So from that data granularity, that's there. I think one of the other points you bring up with data analytics is that we're also developing and improving the ability to manage large volumes of data and learning new things about it. And we're working with artificial intelligence engines on things like looking at blade photos and vibration data. And one of the things I find, that is very difficult to show out there in the field is case studies about which type of analytics is actually the best, which one brings the owner the most value, and a case study with a side-by-side between two analytics methods. And what I find is selling, and that is appealing to owners, and it would be nice to gauge the audience, is the providers that are quick and easy to work with and have a lower price point, even if the quality of that analytics isn't as good, because it's so difficult to compare something that someone says is so much stronger. That I think is just a challenge I hope our industry takes on and gets better at in the future, so that we really understand the overall effect of 5 and 10-year analytics versus some of the short-sightedness that we're all forced to deal with urgent business needs. So are there any other points on data analytics? Because that's a very big topic as well.
Yeah, a couple more points. So let's have a look at this one here. So an owner says that they're struggling with basically the sharing of diagnostic tools that can enable them to enable them to maintain their own WTGs. how does Siemens Gamesa work with owners to enable them to be self-performing on a daily basis after the warranty or O&M contract expires? Can an owner ever expect to be self-sufficient, or should they prepare a budget for the life of a project to include that sort of service?
Yeah, I think one way or the other, you need an in-house plan, or you need to work with a partner. Right? If you do nothing and expect the assets to run, I would firmly state that you're missing on opportunities. You're not seeing something that could be better. That could be anything from proper fault trend analysis from your SCADA system. That could be your power curve on your asset. That could be drivetrain health. All of those things, I would say, we now consider vital components that, again, 10 years ago, when things were booming, we really weren't putting as much of an emphasis into, just across the spectrum, both owner and manufacturer side. So how do we help with this? We provide what we think are competitive solutions. There are great third parties out there trying to do the same thing in a very competitive space in North America. And we can do everything from help someone with SCADA health reports, to SCADA trends and proactive analysis, to drivetrain monitoring, to some of the artificial intelligence engines that help owners get that knowledge to control the business. And if I think I'm an owner, I think it's a tough situation out there right now to vet all of the options out there available to folks for all of those things, because there's so much data and so many people looking in that space now. But again, summarizing my answer here is you absolutely have to have an in-house plan to take that all on yourself, a hybrid to do some of that and work with partners, or you just need to work with partners who you enable to have that data for controlling those business decisions. Absolutely vital.
Okay, great. Thanks very much. Oh, sorry, I was just sifting through the remaining data analytics sort of questions there. We've also had a couple of responses back about the wedge issue that you were talking about earlier. I'm going to stick with the data one very, very quickly, because that could be a reasonably quick answer, and then I'll return to the wedge one. So someone's asking about whether or not you provide only analytic solutions after the warranty.
So there are options after the warranty, indeed, and I think there are many things happening during contracts, as I mentioned before, that many owners, operators, engineers, and asset managers probably aren't aware of. I would encourage folks to understand, what is it that an OEM is doing or a service provider is doing, and how do they do that? What's the method and the means that those service providers are providing analytics while there's a contract there, so that if you change service philosophies or service providers, you have a deliberate and assigned plan for what is being managed and what isn't during that change. And I've seen changes occur across different spectrums where, when that is overlooked, folks are scratching their head later wondering, why isn't the asset performing? How did we miss this? And that's because I don't think that data analysis had been managed. And we all saw that. I would guess most people on this phone who've been in the industry a decade or more have seen that gap surprise people at times. But to answer that question in short, Ben, yes, that's available for owners aftermarket if they reach out to us. We have a sea of solutions we'd be happy to help people with.
Great, thanks very much. And someone's asking here again a little bit related to that too, is about gearbox oil. So can data analytics be applied to oil analysis, and is that something that you've got a case study experience with?
I think the answer is absolutely. Tribology is alive and well globally in other industries, and the ability to look at that data and to get good quality samples and some of the technology to look at the data online instead of having to take samples is getting better and better all the time. If you Google tribology and you look at that, you will quickly appreciate that is the same as the blood in our veins for you to understand how your asset is performing. And that is something that yeah, we've helped with before with things like metal particle counting. There are other methods such as vibration analysis that you can do separately or together with tribology management. But yeah, a critical part of drivetrain health, not unique to the wind industry at all.
Absolutely, and I think one of the key sort of agreements in the conversation that we're having between myself and the chat right now is that people need as much technical data as absolutely possible to ensure that they can run their asset properly. One of the other things that someone has mentioned here, just going to pull that one up because it was a good one, regarding CMS. So quick look. Here we go. So regarding turbine CMS modernization, this is from Stephen. So operators are starting to retrofit thousands of advanced wear debris sensors. Is that something that you're looking into at the moment? And is that something that you're chatting about a lot with your customers? And is that something that you're providing advice on?
Sure. In general, I think when we answer this question, it's very important for the owner to think about what type of situation their asset is in. So I say that because you need to run the business case based on if you already have existing equipment in the asset that is providing you data on vibration, temperature, faults, or metal. If not, if you have nothing, your business case needs to evaluate the hardware options. If you already have something, you need to evaluate the analysis options because there are a variety of different ways to analyze information. Everything from statistical Weibull analysis from old data to online trending with primary component analysis to your other features of artificial intelligence, which is looking at a more complex method of pattern analysis to tell you what we think is going to happen in the future. So more specifically, are we looking at anything? At Siemens Gamesa, we are really built upon an artificial intelligence engine called Pythia, which is capable of detecting subsurface anomalies. And we have previously developed some metal particle counting, but we are not doing that as much as we are reinforcing our vibration philosophy.
Brilliant, thanks. A lot more questions coming in about analytics, monitoring, and data as well. So, excuse me, these are quite long questions, but they're fantastic, so keep them coming. The latest one was, how much of an opportunity is there for owners to upgrade the control systems on older turbines? Is that a challenge because the control systems are proprietary to the OEM? How much of an opportunity is there, therefore, for the owners to upgrade on that one? Sorry, they just wrote the question twice. So yeah, I'll repeat that again. How much of an opportunity is there for owners to upgrade the control systems on older turbines? And is that a challenge because they are obviously proprietary to the OEM?
I think that's probably one of the most challenging component sections of a turbine. And we've seen that with some of our repower experience where, we mess with old controllers and new controllers and just imagine the amount of endpoints and parameters that have to be aligned, and I think you can appreciate that. I also question the cost effectiveness of controller system overhaul versus other means, and that question comes up quite a bit. I think if you're looking at supporting something that you don't have OEM support for, and you get into, I think, a very big challenge for the OEMs is working on controller systems on other OEMs' towers. So that puts some legal and proprietary barriers in the way that then suggests that that's something owners might work on with controller designers. But they also have to be very careful about working on another manufacturer's controller with another manufacturer. I think that is commercially very complex. I think it's technically very complex, and therefore I would say, due to high complexity, something that we're not going to see a lot of, and we're not developing a lot of. That is not a strategy that I would highlight right now.
Okay, great. Thank you. And the next one, again, sort of similar about data analytics is, what about monitoring properly grease analysis for pitch and main bearings? Can you provide acceptable levels for particles, sizes, and quantity?
Can I? No. I think we certainly have the engineering to do that, to work with grease and oil analysis. And again, that's something not unique to the wind industry, but something that we're all starting to look at now because of some pain points we've had. And I'm speaking from my experience on multiple platforms where we have these metal on metal surfaces. That are the places that take on most wear. So if I'm an owner, there certainly needs to be an in-house hybrid or partnership program, making sure that that feature is managed to avoid higher costs of component failures later. But no, I can't get into any technical details on the particle
Of course.
science, if you will.
No problem. No, but thanks for that. Let's have a look here. So another one about SCADA, high frequency SCADA data. So 10-minute resolution under 10-minute resolution. So greater than. Are you doing anything with this? How easy is it for owners to obtain high frequency data?
It's a phone call away. So we can help with higher granularity data, and we do that with owners today.
Right. Okay. Got lots of questions coming through. I'm just trying to pick through them all to make sure I'm not leaving anybody out. We do have a response to the wedge topic from earlier, if you don't mind moving off the data one.
Sure.
Okay. So the wedge issue is something that a couple of owners have identified that they're having a problem with at the moment in their facilities. They really want to find out if there's any new advice on this issue. It seems to be sort of that run to failure is quite a widespread approach at the moment, and some owners are wondering if there's any new advice out there at the moment.
No, and I wish there was. I personally work on that issue as well with different manufacturers, and at one point a sensor supplier that had something called the black box, and I got so excited. we were testing to see if we could proactively identify it. I've worked with partners who have worked on vibration analysis to proactively catch it, and that I would say is one of the lingering challenges in the industry from my perspective, Ben, that has yet to be shifted into the proactive section. So if an owner is doing an overhaul or a repower, then if there is a question about the integrity of the wedges, then the best advice for folks right now is unfortunately to save in mobilization costs, right? And to try to identify cost-effective replacements with one mob. Again, that falls into the run to failure category, and we should highlight this as an ongoing opportunity in the wind industry across multiple types of generators, multiple types of operating settings that I haven't seen anybody put their finger on yet. Okay,
brilliant. Thanks very much for that. And I hate to actually move on, but just looking at the time, we've got about 20 minutes left, and I realize we have 2 more slides of question sort of formats to go through. What I would say is if anybody has questions that haven't been answered that they really want Sam to answer, we don't get time for at the end, because I will revisit if we have the time, please resubmit and put a question mark, a couple of question marks before it, and I will pass it on to Sam, and he can answer it in his own way, and I can introduce him to you if that's your wish. Just give me an email when you get the recordings. Sam, sorry, I hate to push you on to the next slide, but if you wouldn't mind, there we go. Great.
Sure. So the next slide is a similar format, and I'm looking for ideas on this concept I introduced earlier about mutual benefits. So what are ways that work well to help the manufacturers provide support with aftermarket owners' needs in a mutually beneficial way? And of course, I suggest I'm looking for good practices from the audience to hear about what works that's proactive versus the fire drill. How do we avoid the outage scenario? And so often that we're on the phone on Saturday mornings and Sunday mornings supporting each other. What can we do differently there? What are the considerations that vary with the asset life cycle, with new turbines, middle-aged turbines, and now a lot of our modern turbines going into their last third in their design life. What are the relationship best practices? What are some positive things out there from the audience that we can touch upon? Does it make sense for owners to say, hey, we're going to partner with you to help you support us with exclusivity in exchange for some kind of enhanced bonus or LD if you can't deliver? And I bring that up in light of a very healthy and competitive RFP market that I know many colleagues on the call and I compete against and partner with sometimes. And then any other ideas, but this concept of mutual benefits. How do we all get better together? I'll pause there, Ben.
Great, thanks very much. So everyone, get your questions in, your comments in now. I'll start seeing them and feeding them back to Sam once they get through. A very, very quick reminder that we do record this webinar, so if you want to hear all this back, I will share the slides with you too. I will send this all once the recording is uploaded onto Vimeo, and I'll send it all to you in email. If you have any questions that aren't getting answered just because of the high volume that we're getting, and sorry for that, like I said, put 2 or 3 question marks before that, and I will pass it on to Sam, and he can get back to you about that particular question if it's really burning in your mind and you'd like to know more. Let's have a look. Okay, keep those questions coming in, those comments coming in. Okay, here we go. So Sam, have you considered another method of monitoring? So this might be actually based on the last topic, but we're just waiting for the rest of them to come in. So have you considered another method of monitoring, which is actually high frequency, like torque data, torque ripple, or torsional vibration? It's a simple concept that's used in something that the marine industry does, and it's simpler and cheaper. Is that something that you've heard of and Siemens Gamesa are working on, or anything like that?
The question's about torque monitoring?
Yeah, it's about sort of, I'm just reading the question again. Using another method of monitoring, which is high frequency torque data. Torque ripple and torsional vibration is what they said. It's something that apparently the marine industry uses. Paul, you were the person who asked the question. If you could follow up on that, that would be great. Add some more clarity, and I'll relay it to Sam. Let's move on to the slides.
Yes, we know that torque's a characteristic of the drivetrain that most of our controllers manage, and there are varying degrees of diagnostics models. And for example, we have one called model-based diagnostics, which has the math that has no numbers kind of level of sophistication that is putting together reports from all of the different sensors and all of the controller features in advanced algorithms to preventatively, proactively catch things. This is absolutely critical in the offshore industry because they can't have turbine trips. And that offshore industry that many of the manufacturers are a part of is driving so much of our analytics and O&M practices, such as what's the mean time between visits? How do we avoid going to the turbine? Because we cannot afford to send a ship or a helicopter out to a turbine multiple times a day to troubleshoot it. So I would kind of defer that into a general category and say, yeah, torque is involved, but I can't speak to torque frequency and frequency science either.
No, great. No, I appreciate that. And I'm still waiting on the follow-up from that. So if there's anything else, I'll relay back to you. But we have had a question come in about end of life cycle for blades. What sort of solutions are you exploring at the moment for the end of life in regards to blades? End of life, of course, is a massive consideration for owners right now as the fleet gets older on average. And how do you keep it sustainable as well?
Yeah, great question. And yes, something we're all seeing every day. In general, this is a story about the same tone I shared earlier about how the industry's changed. And so much of what we did was we put things up, and then when it broke, we'd go fix it. But now we're really emphasizing the importance of considering a blade maintenance program that includes your exterior and interior inspections. So we're able to take photos from ground-based photos, from aerial drones, put that into what we believe is one of the world's leading annotation engines we call Hermes, and it is able to provide a report extremely quickly, stitch the pictures together, and help owner engineers assess the condition rapidly. We believe in this so much so that the vision of the future is that eventually this will happen automatically, and repair crews will be able to go directly out to the turbine without engineering intervention whatsoever. The same is true with interior blade drones. We are developing an interior blade drone which will prevent technicians from crawling in a confined space and bring much more rapid information to the asset manager and bypass the engineers looking at pages and pages of photos. The theme here is that an owner needs a maintenance plan. Otherwise, their maintenance is going to be a spike every year when something is detected. And we know that's difficult to manage. So we want to get to a point where we understand a year-over-year cost on inspections and repairs. And I think by getting more proactive and getting better at detection and understanding failure modes, we're going to see blade maintenance become less and less of a concern. On the other hand, as the turbine models change, as an owner, this is an extreme risk in that many of those blade models aren't made anymore. And so I think that's something that's difficult to take into consideration, when new turbines are being purchased. But something that I think, not the service team that we do, but our new unit and turbine purchasers have to factor in with that overall cost of ownership and risk with that component in the wind industry.
Brilliant. Thanks very much for that. And we're getting quite a few more questions in now about things like the life cycle positions and things like that. So I'm going to sort of carry on here. We've only got about 10-15 minutes left. Can you describe sort of the three different life cycle positions, early, mid, late? This particular company runs on a time-based maintenance. Are there monitoring points that dictate early, mid, and late? Blade controls, generator, and tower standards is what they've put down there.
I'm not sure I understand that question.
Of course. Neil, if you were the contributor, you asked that question. If you wouldn't mind just following up a little bit with some more detail, that would be great, and I'll move on to the next one now. Let's have a look. Are you, so here's a question from Sam, a different Sam. Is Siemens Gamesa developing or working with a partner to focus on rotor root leakage, looking for solutions to improve AEP, reduce vibration by evening out the pressure differential?
Well, absolutely. I think we've seen the aerodynamics emphasis improve also, in the past few years. Where many of those are initially better just from the out of the factory design. Many of those out of the factory come with improved aerodynamics and VGs, and that's another science in and of itself. I'll avoid technically, but yeah, we know most of that benefits coming from the longer part of the blade, not the root area. So no, I can't speak specifically to rotor root leakage, but we can address that. We do have methods to improve the overall aerodynamics with things such as dyno tails, VGs, winglets, like you see on the airplanes we all travel on.
Okay, great. Let's have a look. Got a couple more questions coming in, but I'm just very, very wary of the time because we have got a third slide go through. Yeah, let's move on there so we can get the final one in because we've got about 7 or 8 minutes until we have to start wrapping up. So Sam, if you wouldn't mind sort of explaining what your thoughts are on this one here.
Yeah, so here I think is that the OEM solutions aren't always the best for the owners, and so trying to stoke some discussion here about when is and when isn't an OEM solution the right fit for the owner's needs versus in-house and market alternatives. And we talked about that earlier. That oftentimes it makes sense to have a hybrid solution if you don't have a big back office, and if you do have a big back office, how do you keep that that in-house capability in check with the market alternatives? Those attributes, of course, are starting with money, right? What's the competitiveness and the business case for the owners? How innovative do we find is the OEM versus the third-party niche market? How is the trust and transparency? So someone asked about blades, and I would say, how many folks really want the person who made the blade to come out there and help? There's actually some pros and cons to that, right? Ease of work. The OEMs are big organizations. Is it easier to work with smaller companies that are focusing on one product, or do you have to manage 20 of those smaller companies, and is that too tedious? And then along the same lines, the niche third parties versus the OEM product line, that can be the one-stop shop. What are some of those pros and cons that folks might want to share or ask about?
Great, thanks very much. So yeah, while everyone's typing in their responses and their thoughts on that, let us know what you think to those points just there and which ones you perhaps agree with and where you lean. And just a final reminder as well that all of the audio and the presentation recording that you can see on your screen throughout the webinar is being recorded, and we will send it to you most likely tomorrow or Monday morning. And also, if you have any questions for Sam and the Siemens Gamesa team, please do send them to me via email that I don't get to answer today. Apologies, I can't get through them all. There's so many. And I will pass them on and they can get back to you in due time. So let's have a look. Right. Just waiting for... people are asking for your email, Sam, so that might...
I'm on LinkedIn. That's the easiest answer.
He's on LinkedIn. Yeah, grab him on LinkedIn. It's Sam Tasco, Samuel, I guess. Okay. Sorry, just trying to pick through some more here. Keep them coming, guys. These are some great questions. We actually had we had some more clarity about the early, mid, and late life cycle question as well. I just want to touch back on that so we get that one answered while everyone's writing up their answers for this one. Basically, the question was really, are there benchmarks for the different components that you offer, I guess, that define where they are in their life cycle, so you can say, oh, we're now here. And if they would take over a contract, the company in question, they would obviously want a better understanding, so having benchmarks in place would be really beneficial. Is that something that you do, benchmark the life cycle of different components?
Yeah, I mean, absolutely, right? Everyone knows that everyone's looking at failure modes when you're looking at, or not failure modes, but failure rates when you're looking at service contracts, and there's certain years that make more sense than others, and I think the savvy owner knows that, and they're going to take that into negotiations, especially if they're expecting the OEM to take on that risk. Another way of considering that, though, is that aside from the service contract term and specific component failure knowledge, is considerations about the loads impact, because we say these are typically certified for 20 years. That may be getting longer and longer also. But when we say it's certified for 20 years, it doesn't mean the asset self-combusts or falls over at 20 years. It means that's what this load life can be certified for. And within there, then you get a variety of things that are affected differently based on the design versus the actual loads that those assets experienced. This falls into what the industry calls a lifetime extension, meaning what can we look at that could be weak, inspect it or mitigate it, and keep this asset running longer. And that's supported by third parties as well as by SGRE, and there's some pros and cons when you work with or without the designer, such as things like aeroelastic loads that are proprietary to us, but that we can support on other platforms because it's just loads data. It's the smart math teams looking at math equations and much very very sophisticated analysis models. So that's my 2-segment answer there, Ben.
Thanks very much. And just very conscious of the time here, so we've only got 5 minutes left, and either people are taking a lot of time to write their questions for this particular section, or there's not too much to comment on. So we're sort of rounding off now, which is great. A lot of people are saying thank you, which is great. So Sam, I think what we'll do is we'll round it off here as it is around about 5 to the hour. So before we get actually I'm gonna squeeze in one because I've just got one here. Can load lifetimes be adjusted periodically through the operational lifetime, similar to the rolling AEP? And that's from Barry.
Can load lifetimes be adjusted? I'm going to take a shot at this. We're working on a tool that would actually allow owners to change settings on the turbine that allows it to take on more AEP at the risk of more loads, or vice versa, less AEP to maintain the load integrity, kind of like a dynamic drive like you have on a car with a Sport Plus mode. And so that's something that we're hoping to put into the hands of the owners to make those decisions based on the site economics and the asset need. Otherwise, without an analysis, then you need some kind of dynamic tool like that to achieve that question.
Great. Thanks so much. And sorry, we're getting a couple more questions. Oh, well, Barry says exactly, and thank you very much. So that was a great answer there. So that's actually all the time we have for today. I'm really sorry that we couldn't get through everyone's questions. I've been sifting through them as fast as possible. I will pass on all the questions that were asked during the webinar to Sam. And if you contact him via LinkedIn for your question as well, he'll be able to give you an answer. Or you can reply to me, and I'll pass on any additional questions that you may have to the team. So yeah, thanks very much. Thanks, Sam, very much for your contribution today. It's been fantastic having you here interacting with the industry.
No, thank you all. It's amazing how quick an hour goes, and I appreciate the interaction, and I appreciate being a part of our industry. I'm proud of everyone I meet every time we get out to these conferences, and what we're doing with wind in North America. So thanks for having me again, Ben.
Yeah, thank you, Sam. And Sam and the rest of the Siemens Gamesa team will be at Wind O&M Dallas this April 16th and 17th. He alluded to it earlier. And there are silver sponsors for the event. They're going to be down in force and talking about the various different topics that some of them that we've covered today and in other parts as well. So make sure you're there as well. If you need any more information, just please ask me once I send you the recordings, which will be either tomorrow or Monday. But apart from that, thanks very much, everybody. Thank you very much, Sam. Have a great day. Have a great Valentine's, all of you, and talk to you soon. Thanks very much. Cheers.
Happy Valentine's.